to do is solve some more inequalities, but these time they're going to be quadratic inequalities. Well, quadratic again means that you've got that x squared term. Well, the easiest way to solve a quadratic equation, a quadratic inequality, is going to be very similar to how we did the equations, which is making sure that one side is 0. So we'll make sure that one side is 0. But the difference here is because we've got an inequality, what we're actually going to want to do is graph it so we can see what the picture looks like. With these inequalities, if it's anything more complicated than just an x, when you see an inequality, then what we're going to want to do is graph it. And when we do this, we're going to hinge on the fact that we need to know that one side is 0. Why? Because if we talk about our graph being bigger than or smaller than 0, well, 0 is the x-axis when you're graphing. So anything that is greater than 0 is up top. So the up top portion is anything that's greater than 0. And anything below the x-axis, anything that's negative, is going to be less than 0. And then when you're actually equal to 0, that's when you actually land right on the x-axis. So what we're going to do is set these so that one side of our inequality is 0, so that we're either going to be simply talking about either what's above, or we're going to be talking about what's less than 0, what's below the x-axis. So remember, though, for graphing something that's quadratic, it's going to be a parabola that we're graphing. So that's kind of another thing to keep in mind, is when you've got an x squared, what kind of shape are we looking at? We're looking at a parabola. So let's try an example and see where this is going to go. So we're going to eventually want to graph this parabola. We'll start off by doing something like this. We'll start out with a blank graph. Continuing along, let's talk about solving quadratic inequalities. So like we said, the key is making sure that one side of the quadratic inequality is 0, and that the other side has your x squared, your x, and your numerical term. And we're going to want to make sure that all of our solutions are in interval notation at the end. But let's work about how to solve this first. Before we do anything, we're going to be worried about when it is actually equal to 0. So ignore the inequality first, and let's worry about the first thing, which is when the x squared minus 7x plus 10 actually just equals 0. Because when that happens is when you're going to cross the x-axis here. Is when you actually equal 0, is when you'll cross the x-axis. So let's start by going ahead and figuring that out. Well, when something equals 0 that's quadratic, we're hoping that it will factor. That's always our hope. Well, this thing factors. We would need 2 factors of 10, positive 10, that add up to a negative 7. Well, there are indeed 2 factors of positive 10 that do add up to a negative 7. And well, we have to start out with our x's, but the 2 factors that multiply together to give you positive 10 but add up to negative 7 are negative 5 and negative 2. They do multiply together to give you a positive 10 and add up to a negative 7. Once things factor like this that are equal to 0, then we go ahead and set each piece equal to 0, which, when we solve that, on the first one, we'll go ahead and add 5 to both sides. And on the second one, we'll add 2 to both sides. And let's see what that gets us. On the first one, that gets us x equals 5. And on the second one, that gets us x equals 2. And remember, these are going to be our two spots where we're going to cross the x-axis. So I'm going to cross the x-axis here at 2 and at 3, 4, 5. The next part of this is remembering what kind of picture this is. Remember, because we have something that's quadratic, something with an x squared, it's going to be a parabola, a U shape. Now, it's going to be, the question is an upward U or a downward U? Well, it's going to be an upward U because the a, the value that's out in front of the x squared term, is a 1 and it's a positive 1. So that means we'll be looking at a parabola that's U-shaped going upward because a is positive. That number out in front of the x squared is positive. So we don't have to be perfect, but we just want to make sure that our U shape goes through those two values and is the U shape pointing upward. Now, the question is, what did we actually want to do in the first part? Well, it says greater than 0, which means we only want the parts of the graph that are up top, that are above the x-axis. We only want the parts of the graph that are above the x-axis, that are up top. And there is kind of a little bit of a problem with that because there are more than one part of this graph that's above the x-axis. There are actually two pieces. It's both of these little tails on our parabola. Now again, the reminder is that we need to write this solution in interval notation, which means using parentheses, brackets, reading this graph from left to right. So we'll start out with reading this graph from left to right, reading this first little portion of our graph, this first tail, which is that it starts at negative infinity and works its way up all the way up to 2. So we have from negative infinity all the way up to 2. So what that would look like would be negative infinity all the way up to 2. And the question would be, am I going to use a parentheses or a bracket? Well, I'm going to use a parentheses because we had greater than, not greater than or equal to in the original problem. If you go back and look, it was a greater than, not a greater than or equal to. So we'll use parentheses. Now, the other part of this graph that's above the x-axis that's greater than 0 is the other side, which starts out at 5 and continues towards positive infinity on the right. Again, we had greater than, not greater than or equal to, so we use parentheses again. Remember, when we have two pieces like this, we have to put them together or unite them with a symbol that's a union symbol that looks like a U. Be careful not to use the U button on your keyboard. That will not work in my math lab. So our final answer is this interval notation here that says negative infinity to 2, and both parentheses on both ends, and then 5 to infinity, parentheses on both ends. However, the parentheses on the 2 and the 5 are because of the greater than, not the greater, the fact that it's a greater than and not a greater than or equal to. The other end, the infinity and negative infinity, always have parentheses no matter what. Let's take a look at another example. Let's take a look at B. In B, we have x times x plus 1 is less than 12. Remember, if something's factored, we want it to have 0 on the other side. This is factored, but it does not have 0 on the other side. So I want to undo the factoring first. So I'm going to multiply or distribute out my x, which will get me x squared plus x. And we haven't done anything to the right-hand side, so just a 12. Then, because we have something quadratic now, we do want a 0 on the right-hand side, so I need to get rid of the 12 by subtracting 12 from both sides. That will move it from one side to the other. And what that now gives me is x squared plus x, and then we move the 12 over with a minus 12. Now is less than. Everything canceled, but there's still something on the right. When you have something and then take it away, we end up with still a 0. So let's take a look and see what this is going to be asking for. This time we want something that's going to be less than 0, which means below the x-axis. Well, first of all, just like before, we need to figure out actually where we're going to hit the x-axis. So, where are we going to actually hit the x-axis means when am I actually equal to 0. So let's look at that first. Is when is x squared plus x minus 12 actually equal to 0? Remember, we couldn't do this, though, until it actually had 0 on one of the two sides. So how do you solve something where it's now an equation and equal to 0 where we're going to factor? Well, that would mean we want two factors of negative 12 that add up to, it's a hidden positive 1, and that would be a positive 4 and a negative 3. And remember, we start with x's to get the x squared. So the next thing that we can do is factor. We've already factored is take our factors and set them equal to 0. So we've got an x plus 4 that needs to get set equal to 0 and an x minus 3 that needs to get set equal to 0. On the first one, subtracting 4 from both sides gets us negative 4. Adding 3 to both sides on the second one gets us a positive 3. So those are the two places where we're going to cross the x-axis, is a negative 4 and a positive 3. So let's go ahead and label those on your picture. So here's negative 4. That's where I'll cross the x-axis in one spot. And here's the positive 3 where I'll cross the x-axis at another spot. Okay, now remember this is a parabola. It doesn't have an x squared term, so it is a parabola. It has a hidden 1 out in front of that x squared term. It's a positive 1, which means that our parabola is going to point upwards, so it doesn't need to be perfect. I don't know how far it's going to dip as of right now. I just need a generic picture. Okay, so I've got my generic picture. Now the question is, what was I looking for again? Well, remember I wanted which part of my graph was less than 0, meaning below the x-axis. Let's see, which part of this graph is below the x-axis, is falling in this shaded region. Well, there's only one part. It's this little dip. Notice that's going to be a really nice one, is the interval notation, reading it from left to right, starts at negative 4, ends at 3, and continues everything through the middle. So our answer for this one in interval notation will be that the graph that's below the x-axis starts at negative 4, stops at 3, and just like before, because we've got less than, 0 not equal to, we'll use parentheses, not brackets, on both, and we're done. That is our final answer in interval notation.